We're going to talk about a really powerful way of factoring polynomials called the rational roots theorem. And here's one of the main ideas that we need to keep in mind when we're factoring larger polynomials. And it's something called the remainder theorem. So the remainder theorem, you actually already have a good idea what the remainder theorem says. It's just that you're used to dealing with numbers and not polynomials. So for starters, if you wanted to answer the question, is 3 a factor of 51? Probably what you would do is divide. 3 goes into 51. And I'll do the division really quickly. So 3 goes into 5 one time. 1 times 3 is 3. Subtract and get a 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. And when we subtract, we get a remainder of 0. Since we get a remainder of 0, then the answer to the question, is 3 a factor of 51, is yes, since our remainder is 0. Now, on the other hand, if we got rid of all of that and we asked instead, let's say, is 3 a factor of, I don't know, 56? That seems reasonable. Whoops, let's erase this and make it a 6. Same thing, 3 divided into 56. 3 goes into 5 once. 1 times 3 is 3. Subtract. Bring down the 6. Now 3 goes into 26. What is that? 8 times? 8 times 3 is 24. And 26 minus 24 is 2. The remainder here is 2, which is not 0. So since it's not 0, that means that 3 is not a factor of 56. So the remainder theorem is a concept that you already have a good understanding of. If you do, or if you're checking if some number is a factor of something else, you divide and you see what your remainder is. If the remainder is not equal to 0, it is not a factor. And if the remainder is equal to 0, then it is a factor. So let's extend this to some polynomials. So let's go now to x minus 2. Is x minus 2 a factor of x squared plus x minus 6? Now, hopefully, you know a bit about factoring, and if you do know a bit about factoring, kind of off to the side here, I want to remind you that x squared plus x minus 6 factors to x minus 2 and x plus 3. So it is a factor. But I want to show you how to get that same result without using factoring. So we're going to use division. And I'd prefer to, if we can, not use long division of polynomials. Here I'd like to use synthetic division. Okay, so remember, if you don't remember synthetic division, I have a couple of previous videos posted on how to do synthetic division. So here's how we would write this. If we wanted to divide x minus 2 into x squared plus x minus 6, here's how we would write that in synthetic division format. The number up in the box in the upper left-hand corner is 2, coming from x minus 2 equals 0 and solving. The numbers outside of the box but on the same row are the coefficients of our x squared plus x minus 6. So that would be 1, 1x, and negative 6. Leave a blank row, draw an underline, and we begin by bringing down the 1, the first number, multiplying by the 2, by the number in the box. So 2 times 1 is 2, and writing that result underneath the next number. Add vertically. 1 plus 2 is 3. 2 times 3 is 6. putting that underneath the next spot, and -6 and +6 is 0. And if you remember synthetic division, this is an overly simplified way of writing your answer. The number at the end is always your remainder. And the number in front of your remainder is always your constant. And the number in front of that is always the coefficient for the x term. So if we divide x minus 2 into x squared plus x minus 6, we get x plus 3 with a remainder of 0. But we knew that by factoring. X minus 2 and x plus 3 are the factors. So here's what that means. Since we got a remainder of 0, that means that the answer is yes. X minus 2 is a factor of x squared plus x minus 6. Now let's extend that and make that even more challenging. Let's say that we were asked the question, is x minus 2 a factor of, let's say, 2x cubed plus 11x squared minus 7x minus 6? Now, I teach a lot of algebra. I factor a lot. This is a challenging problem to factor. In fact, the normal methods that we usually cover in an algebra class won't help us factor that polynomial right there. So it's not as easy as x squared plus x minus 6 was. So we're again going to use synthetic division, and we're going to see what our remainder is. So again, when we're doing the division, x equals 2 is the number in the box. Outside on the same row are my coefficients of the 2x cubed plus 11x squared minus 7x minus 6. That'll give me a 2, an 11, -7, and -6. Bring down the first number, 2 times, multiply by the 2 in the box. So 2 times 2 is 4. Add vertically, 11 plus 4 is 15. 2 times 15 is 30. -7 plus 30 is what, 23? 2 times 23 is 46. This isn't looking good. And -6 plus 46 is 40. Well, in order for x minus 2 to be a factor of 2x cubed plus 11x minus x squared minus 7x minus 6, this remainder has to be equal to 0. And since it is not equal to 0, then the answer to that question is no. X minus 2 is not a factor of 2x cubed plus 11x squared minus 7x minus 6. So let's change it. Let's ask a different question. Let's ask the question is, if x minus 2 isn't a factor, maybe x minus 1 is a factor. So let's do the same question with x minus 1. Okay, again, I'm going to use synthetic division because I prefer it. It's a little bit quicker. Now the number in the box, when I set x minus 1 equals to 0, the number in the box is 1. The coefficients of the 2x cubed polynomial are 2, 11, -7, and -6. I'm again going to start by bringing down the 2. 1 times 2 is 2. 11 plus 2 is 13. 1 times 13 is 13. -7 plus 13 is +6. Ooh, this is looking good. And 1 times 6 is 6. -6 plus 6 is 0. Great. This is our remainder. And if we just need to answer the question, is x minus 1 a factor of that larger polynomial? Since our remainder is 0, we have enough information to say yes. X minus 1 is a factor of the larger polynomial. Moreover, we know even more information of that. Than that. We also know now that 2x cubed plus 11x squared minus 7x minus 6 can be factored at least partly by the x minus 1 because it was a factor. The rest of it is given here in our answer. 2x squared plus 13x plus 6. And even further, if you know how to factor more, you could keep going and factor that entirely all the way through. And you could get an excellent factorization of the 2x cubed plus 11x squared minus 7x plus minus 6 that we weren't able to do prior to that. And that factors to be 2x plus 1 times x plus 6. So we have just successfully factored the beast 2x cubed plus 11x squared minus 7x minus 6. Let's try one more example. Let's try the example of is x plus 1 a factor of x cubed plus 2x squared minus 5x minus 6. Okay, we could use long division, see if the remainder is 0. We could try, by methods that I am unfamiliar with, factoring this beast right here by previous methods, but I think I would like to use synthetic division to check. So the number in the box, if we take x plus 1 and set it equal to 0, we get negative 1. The coefficients of our larger polynomial are 1, 2, negative 5, negative 6. And we start by bringing down the first coefficient. So bringing down the 1, negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Multiply by the number in the box. Negative 1 times 1 is negative 1. Add negative 5 plus negative 1 is negative 6. And 1 times negative 6 is negative 1 times negative 6 is positive 6. So that is wonderful. We have a remainder of 0, which means the answer to the question, is x plus 1 a factor, is yes, x plus 1 is a factor. That also means that we can write x cubed plus 2x squared minus 5x minus 6 as x plus 1 times whatever leftovers we have here. So in that case, that would be a 1x squared plus a 1x minus 6, which is actually something that, again, we know how to factor that. So we could even go one step further. X plus 1 stays on the outside, and x squared plus x minus 6, that factors to x plus 3x minus 2. So again, we've successfully factored x cubed plus 2x squared minus 5x minus 6.